So planning experiment 2020 papers. The first one from Feb March 2020, paper 6 variant 2. In the question, a black dye can be obtained from some plant roots. So we can obtain the black dye or a black color from different plant roots. We have to plan an investigation to determine how many different colored substances are present in a black dye from a plant root. So how many different substances are there? We want to identify. So whenever we are identifying the number of the colors, identifying different colors, so we always use a chromatography. You must include how the results you obtain will tell you how many different color substances are present in the black dye. You have access to plant roots and normal lab apparatus. So first we have the plant roots, but using a chromatography, we can work out how many different dyes or colors are there in this plant root, but we have to extract the color first. So how we can extract the color? So first thing, we have to crush. Why we have to crush? Because when we crush substance, it will have a large surface area, so the reaction rate will be faster. So we can extract the color quickly. So first we crush by using a mortar and a pestle. And as they did not mention that the color is water soluble or insoluble, so we can boil in water. Whenever we boil a substance in water or boil in a specific solvent, we can extract the color. So first what we will do, we will take the plant roots, then we will crush them by using a mortar and pestle. An example, these are the plant roots. After crushing, we will add water and we supply heat energy to extract the color, because in a hot solvent, the rate of a reaction will be faster, so we can extract the color quickly. And when we extract the color from the plant root, we will place a sample. We'll use a chromatography, draw the origin with pencil and place the sample on the chromatogram by using a dropper or a teat pipette. Then using a suitable solvent, we can use water here as well. And we'll wait until the solvent reaches the top. And how we know how many colors are present in this plant root? So the number of the spot, like example, if there are 3 spots, it means the 3 different colors are there. If 5 spots, it means 5 different colors. So the steps, first we will crush by using mortar and a pestle. Then after crushing, we can add water and boil to extract the color. After we extract the color, we will use a chromatography. Draw origin with pencil. Place the sample or the extract on origin by help of dropper or a teat pipette. Then use a solvent, like use water as a solvent. And we'll wait for the solvent to rise till the top of chromatogram or paper. And how we'll know how many different colors are there? So the number of the spots represent the number of colored substances, or we can say dyes. Another experiment, this was from Feb March session. The next one is from May June session. Always the last question is related to planning of experiment. We have cobalt, manganese, and nickel are the metal. They react with hydrochloric acid to form a hydrogen gas. We have to plan an investigation to find out order of these three metals, like which is more reactive in terms of like more reactive, moderate reactivity, and the least or the less reactive. We have a sample of each metal. We have a dilute hydrochloric acid. We have common lab apparatus. You must make So you must make it clear how your investigation will be fair test and how you will use your result to place the metal in order of the reactivity. So basically, for a fair comparison, we should take equal mass and equal concentration of the acid and equal amount of acid. So what we will do, as they mention, it is giving off hydrogen gas. So we can measure the rate of the reaction. We'll take equal amount of hydrochloric acid in a conical flask. Then we'll place a piece of metal, equal mass, like starting with one of them. Example, we start with cobalt. After that, we'll collect the gas given off. For example, hydrogen is there. So we can collect the gas which is given off here. Either using a gas syringe or gas jar can be used. Hydrogen is lighter than air, that's why it will always move up or rise up. So either we can measure the volume of a gas because we want to measure the volume. So gas jar is only to collect the gas, but to measure the volume of a gas, we should always use a gas syringe. So we'll start the timer when the acid is mixed with the metal. We'll start the timer and example after 3 minutes, we'll measure what is the volume of a gas, or we can carry out a reaction for like every minute we'll measure the volume of a gas given off. And using a change in volume divided by time, we will find the rate of a reaction. And using a rate of reaction, we can sort out which one is more reactive, which one is less reactive. You don't have to tell the metal which is more reactive or less reactive. You just have to plan an experiment. So what we will do, how we plan, we will take equal mass of each metal and we will transfer them into conical flask by the help of spatula. Spatula or spoon is there whenever we want to add a solid. For example, adding a salt to water, adding any reagent which is solid, we normally use a spatula. So we'll take equal mass of each metal and we transfer them into a conical flask by the help of spatula. Then what we will do, we will add equal volume and concentration of HCl, hydrochloric acid, by the help of measuring cylinder. Why we select here a measuring cylinder? Because if you want to transfer quickly, we prefer to use measuring cylinder. After that, we will place a bung and connect a gas syringe. Bung or a stopper and connect a gas syringe. Start the timer or start the watch and measure the volume of a gas in 3 minutes, or you can say 2 minutes. Then how we can work out the rate, how we'll know the reactivity. So the metal which give greatest amount of hydrogen in 2 minutes is the most reactive. And for a fair comparison, because the reaction rate of a reaction can be altered or can be changed by temperature, so we should keep the temperature same for all the reactions. We should keep the surface area same for all the reactions. We should keep the concentration same for all the reactions. From October-November session. So last question is always, you have to plan experiment and the weightage, normally it's of 6 marks. So all out of 40, 6-mark question is planning of experiment. Another question, a mixture contains 3 solid compounds. We have copper 2 sulfate, we have cetyl alcohol, we have silicon dioxide. The table gives some information about the solubilities of these substances in water as well as in propanol. Propanol is also a solvent which can be like a liquid which can be used as a solvent, dissolve different organic substances. The solubility is given. The copper sulfate is soluble in water and it is insoluble in propanol. Cetyl alcohol is insoluble in water, but it is soluble in propanol. And silicon dioxide, it is insoluble in water and it is also insoluble in propanol. So we have to plan a method to obtain a pure sample of each of 3 solids. Like we want to separate copper 2 sulfate, we want to separate cetyl alcohol, and we want to separate silicon dioxide, all from each other. So what we can do first. So first thing, we'll have a sample, like we'll take them into a container, we can say a conical flask, or we can mention a beaker. Then we will add water, like first example, if we add water and stir the mixture, so copper sulfate will dissolve. So if I add water here, so how we plan this, like we'll take a beaker and we have 3 substances. We have copper sulfate, we have cetyl alcohol, and we have silicon dioxide. But when we add water, so when we add water, copper sulfate will dissolve. So copper sulfate will dissolve in the solution. We'll have an aqueous copper sulfate, and cetyl alcohol and silicon dioxide will be insoluble. So what we should do to remove these 2 substances, we will filter. When we will filter, use filtration. On the filter paper, we will have both cetyl alcohol and silicon dioxide. So cetyl alcohol and silicon dioxide will be there on the filter paper as a residue, and what passes through, that is aqueous copper sulfate. Copper sulfate solution is there. This is aqueous. How I can obtain copper sulfate from a solution? So for this, what we will do, we will use crystallization or evaporation. Either crystallization or evaporation can be used, so we'll have this copper sulfate. Now we have 2 things. We have cetyl alcohol and silicon dioxide. To obtain separate cetyl alcohol from silicon dioxide, now what we'll do, we'll take a residue. What is left in the first experiment, the residue. So we'll take that residue into another beaker, and this time in this beaker we will add propanol. So when we add propanol, cetyl alcohol will dissolve and silicon dioxide will remain insoluble or does not dissolve. Then we will also carry out a filtration second time. And this time when we carry out a filtration, silicon dioxide will be left on the filter paper And what passes through the filter paper is cetyl alcohol. And how to obtain this solid? So we can also use evaporation or crystallization, because this is a solution. So we want to obtain a solid from a solution. We can use either evaporation or crystallization. So the steps we should take to separate copper sulfate, cetyl alcohol, and silicon dioxide. So we will add water to a mixture and swirl the mixture or stir the mixture. Once we stir, we will use filtration to separate copper sulfate from the mixture. Then we will have an aqueous copper sulfate. We will use crystallization or evaporation to remove copper sulfate, CuSO4, from solution. And after that, we will add propanol to residue what was left in the beginning. So we'll add propanol to residue. And again, we will mix or stir. As a result, what will happen? We will again use filtration to remove silicon dioxide from cetyl alcohol. And the last part, from the same thing, cetyl alcohol, we can evaporate to obtain the solid from the residue, from the filtrate.